Hey guys, how you all doing? And it's Jalaj Aura here again, back with another video from BHM at GCSE Chem. And today we're going to be doing C3.5, which is all about covalent bonding. So now we've finished ionic bonding, now we're on section C3.5, and it's called covalent bonding. So that's what the section's called. And I remember actually from my first introduction video, there was actually someone in the comments who actually said, can you go over covalent? I think he said double bonds specifically, but he basically meant covalent bonding. He went, so I'm gonna, obviously go through it, whatever's in the book, and the book I'm using again, it's the AQA GCSE Chemistry Revision Guide from Caboodle. So there it is. That's the book I'm using again, and I couldn't, as if you've been through my, if you went through my, seen my website recently, you would have seen again, I didn't have time to put the links to C3.2, C3.3 and C3.4, so I'll try today, I'll try to put the links to all of them today, including C3.5 after I upload this, on my YouTube channel. But obviously if I can't do it by today, because, I'm quite busy, nowadays, but, but it should be done by the end of this week, hopefully otherwise. But, I'll try and do it today. I'll try and do it all by today, again, like I mentioned previously. So today's all about C3.5 covalent bonding. Now, let's begin now, because I don't think there's anything else to say. And so that's all I wanted to basically say. So C3.5 covalent bonding. So the atoms of nonmetals need to gain electrons in order to achieve stable electronic configurations. Now we know that nonmetal atoms, they tend to form negative ions because they gain electrons. So they gain electrons, so they form negative ions. And just for your reference, as I think I mentioned this before as well, negative ions are known as anions. And positive ions are known as cations. So if you're wondering what the spelling is, cations are CATIONS, and then for anions it's just ANIONS. So ANIONS, anions. So hopefully that makes sense. So the atoms of nonmetals need to gain electrons to achieve stable electronic structures. We've seen this before. We've talked through this before. They can do this by sharing electrons with other atoms. Now, this is the main difference between covalent bonding and ionic bonding. So ionic bonding, ionic bonding happens between metals and non-metals, whereas covalent bonding happens between non-metals only. So, between at least two non-metals, basically, two different non-metals. But ionic bonding, but ionic bonding obviously happens between metals and non-metals. Covalent bonding happens between, at least two non-metals. So no metals are involved in covalent bonding. So hopefully that makes sense. And also, I said that they do this covalent bonding by sharing electrons with other atoms. So basically, ionic bonding involves the transfer of electrons from the metal atom to the non-metal atom, to form positive and negative ions, whereas in covalent bonding you share electrons, and you share electrons, and then both the atoms involved, all the atoms involved basically have stable electronic configurations, or stable electronic structures, and because they have completely filled shells. So completely filled outer shells. So hopefully that makes sense. So each shared pair of electrons strongly attracts the two atoms, forming a covalent bond. So because now we have a pair of electrons basically that are shared, between the two atoms, they now form a covalent bond. So each shared pair of electrons strongly attracts the two atoms, forming a covalent bond. And substances that have atoms held together by covalent bonding are called molecules. So basically, when you have covalently bonded substances, that basically forms molecules. So it might not make proper sense now, but I'm gonna go through it in more detail just soon, in a couple of minutes. But if you're following the student book, by the way, I should have probably said this before, but it's pages 44 to 45. So I do understand that first paragraph maybe didn't make too much sense. Just remember that, I'll explain it further later on, but just remember that covalent bonding happens between non-metals only, atoms are non-metals only, atoms are non-metal elements, but basically when these non-metals covalently bond together, they form molecules, and basically each shared pair of electrons strongly attracts the two atoms, and we call that a covalent bond. So we form a covalent bond basically, when there's a shared pair of electrons between the two atoms, basically attracting both atoms. So hopefully that makes sense. And so, for example, here, hydrogen atoms, one hydrogen molecule, cool. So I think this is a good example here. So hopefully you can see hydrogen, and they both have one electron, obviously, in the outer shell. We know the configuration. Now, if we had to form a hydrogen molecule, both of them would now share an electron, as you can see, and basically then overlap, and the electrons would now basically go in the middle. So now you can see this hydrogen would have two electrons, and so would this hydrogen have two electrons. I think I mentioned this in my ionic bonding, but I'm not sure if I did. Just in case I didn't, basically it works in covalent bonding as well. When you have two atoms and you're showing dot and cross diagrams, one you have to put the electrons as dots, and the other you have to put as crosses. It doesn't matter which one you put as dots and which one you put as crosses, as long as you're consistent and you basically put one as dots and the other as crosses. So the electrons are represented as dots for one of them, and then as crosses for the other one, and you have to be consistent throughout, so that the examiner doesn't get confused, and so that there's no risk of not awarding you the full marks for the questions in the exam. So basically, we know that hydrogen, each hydrogen atom has one electron, in its outer shell. Basically, all hydrogen atoms have one electron in their outer shell. If we have two hydrogen atoms together, they can then share that, one electron each, forming a single covalent bond, which are hydrogen, because only only one pair of electrons are shared. There's two electrons in the middle, so that's one pair. Remember, because it's one pair of electrons are shared, or a pair of electrons. You don't need to say one pair, because a pair is the same as one pair. Basically, that means two electrons are in the middle, so that means there's a single covalent bond formed because only a pair of electrons are shared. And you can see both atoms now have full outer electron. Electronic configurations or electronic structures. So hopefully that makes sense. So here it just says hydrogen atoms with one represents one electron, and then here you form a hydrogen molecule. So when you do the covalent bonding, the compound, what you form is called is a molecule of hydrogen here. So and then in the molecule, next to the molecule, next to where they say hydrogen molecule, like I'm talking about here, the text, what they've written there in black. They've written a shared pair of electrons gives both atoms a stable arrangement and forms a covalent bond. Now a covalent bond is formed basically, and both atoms are given a stable arrangement now because they both have two electrons basically, and that's what you need in the first shell. In first shell you only need two electrons maximum. You can only have two electrons maximum. So hopefully that makes sense. So hydrogen gas is made up of H2 molecules. Both H2 atoms in the H2 molecule gain their stable electronic structure of a noble gas, helium, by sharing a pair of electrons, because helium obviously has two electrons in its outer shell. So they attain the structure of helium. So hopefully that makes sense. Now we're reading ahead. So a covalent bond acts only between two atoms. It bonds to each other, and so many covalently bonded substances consist of small molecules. Sometimes a molecule of substance can contain double. Sometimes a molecule can contain double or triple covalent bonds, as in oxygen molecule in the oxygen molecule shown below. So I'll just show that. soon. But I'll just tell you what that meant again, what it was saying in this bullet point, what this was about basically. Covalent bond. Let me just read that again to make sense of it myself. So, a covalent bond acts between the two atoms it bonds to each other. Yeah, covalent bonds only between the two atoms. Obviously, that makes sense. And so, basically, many covalently bonded substances consist of small molecules. So, many of the covalently bonded substances are composed, or they consist of simple molecules. That's just something to remember, and the covalent bond will only ever act between the two atoms that are bonded together, basically. Between them, basically, that's where the covalent bond will form, and they consist of small molecules. So covalently bonded substances consist of small molecules, basically, and sometimes a molecule can have double or triple covalent bonds, so it doesn't have to be single covalent bonds as in hydrogen. As in oxygen, there's going to be double covalent bonds. The reason why it's single covalent in hydrogen is because hydrogen has one electron in its outer shell, and so if you have two hydrogen atoms, you can only share one electron each, so that you have two electrons in their outer shell if you have two hydrogen atoms. So that means you're going to have two electrons in the middle, which is just one pair. Or a pair, so which is known as a single covalent bond. So hopefully that makes sense. I would recommend you going through pages 44 to 45, which are in the student book, if you don't understand this, because this can be tricky. But obviously, I'm presuming you've already done the content. This is just to revise it. So but if you need to go over it, then do make sure you go through the student book pages 44 to 45 if it's not making much sense right now. But hopefully it is. As it can contain double, a molecule can contain double or triple covalent bonds as shown in the oxygen molecule below, O2 molecule below. So I'll just talk you through this. Here's an oxygen molecule. Here's two oxygen atoms, and you can see oxygen obviously has 8 electrons in total, because it has atomic number 8, so 8 protons and 8 electrons, so there's 2,6 as its electron configuration. Now, both obviously need 2 electrons. So both the oxygen atoms need 2 electrons to kind of fill their outer shells. So that means a total of 4 electrons will be shared. So that 4 electrons is 2 pairs. So that's why it's called a double covalent bond, because you have 2 pairs of electrons being shared. 2 electrons will be shared from the oxygen, from one of the oxygens, and 2 from the other oxygen. And again, it doesn't matter which one you use dots to represent the electrons, and it doesn't matter which of the 2 atoms you use dots and which one you use crosses, as long as you're consistent. And this also works for something that's not identical atoms. Like if you had a molecule of HCl as well, then you could just maybe do the crosses on the H and then the dots on the Cl. Like it really doesn't matter where you put the dots and the crosses, as long as you're consistent for one and then for the other. You're consistent for both. So hopefully that makes sense. So so now both pairs of electrons are shared here, hopefully you can see there are 4 electrons, 2 dots and 2 crosses, because the covalent bond, the oxygen molecule is formed. So let me just read out what's in the black. So this is a double covalent bond. 2 pairs of electrons are involved. Only the electrons in the highest energy level are shown here, or in the outer shell are shown here. You only really need to show the electrons are in the outer energy level. If they don't, most of the time they're going to say, show only the outer electrons, so show the outer electrons only. So you don't need to show the whole kind of configuration, because obviously that can take long. You don't need to show the 2 electrons in the first shell. You can just show the last 6, and then obviously the sharing of the electrons. But they might ask you to draw the full electron configuration. I think it depends on how many marks the question will be worth. But most of the time, they're just going to tell you to draw the outer shells, because obviously it takes time. They want to test you on more things, more topics. So yeah, so hopefully that makes sense. So most of the time, just draw the outer shells, unless specified otherwise, in the question, in the exam, obviously. And then, so now we're going on to the fact that atoms of elements in group 7 need to gain 1 electron, so they form a single covalent bond. So again, in group 7, atoms, they need only 1 electron to form have stable electronic structures. configurations, you could say as well, stable electronic structures or stable electronic configurations. So they're only going to basically, form single covalent bond. Now atoms and elements in group 6 need to gain 2 electrons, and therefore they're going to form 2 covalent bonds. Atoms in group 5 can form 3 bonds, and atoms in group 4 can form 4 bonds. So hopefully that makes sense. Atoms in group 7 can form 1 single covalent bond or a single covalent bond. Atoms in group... Wait, what did I say? Atoms in group 4? No, wait, let me say that again. Atoms in group 7 need to gain 1 electron, so they can form 1 single covalent bond. So they form 1 single covalent bond. Or you don't need to say 1 single, just say form a single covalent bond. Atoms in group 6 need to gain 2 electrons, so they form double covalent bonds. Atoms in group 5, they need 3 electrons, yes, in their outer shell, so they form, so they form 3 bonds, and those in group 4 obviously form 4 bonds. So hopefully that makes sense. So again, here they give other examples where the elements might not be identical. You might not always have H, 2 oxygen atoms, 2 hydrogen atoms. You could have also water, and the principle is basically the same even with water. Ignore the highlighting. I think I was doing that when I was doing my GCSE, so it's quite a long time ago. I was just doing it for my own reference, just to see what's going on. But basically, let me explain it. We're going to draw these structures of kind of hydrogen, oxygen. We know hydrogen needs 1 electron. So in a water molecule, hydrogen's only going to share 1 of its electrons, so oxygen will also share 1 of its electrons, and same with the other hydrogen. And then basically make sure you fill the other electrons on oxygen, so that it has a total of 8, and hydrogen has 2. So hopefully that makes sense. We can represent it using dot and cross diagrams, like this. Or you can even show it without shells like that. Or you can even use stick models like that. Sticks like that to show it. Single bonded, because obviously only 2 electrons are being shared. Because obviously hydrogen can only form a single covalent bond. So that's why there's HOH. And then ammonia again, it involves NH3. That's the formula of ammonia. Again, it's nitrogen with 3 hydrogen atoms. So obviously hydrogen can only give 1 electron. Because it only has 1 electron, can only share a single electron. So ammonia will also share a single electron. There are 3 hydrogens, so basically they're going to be 3 electrons from the ammonia that are shared. And again, 3 single covalent bonds will form. And then you're just going to have to, because if you have 3 single covalent bonds, 3 times 2 is 6. So that means the remaining, you need just to put 2 more electrons there to show the ammonia has, the nitrogen has a full 8, and the hydrogen has 2 its outer shell. So hopefully that makes sense. And again, you can show it like this, or you can show it like that, or you can even show it like this, where you have nitrogen, single bond hydrogen, single bond here, and a single bond here. And again, it really doesn't matter which one you use, which one you put the dots on, which atom you put the dots on, which one you put crosses on, as long as you're consistent, as I mentioned this previously. So this is normally called a ball and this is normally called a stick model. This one's just the same as this one, only this one doesn't show the circles with the shells. This one just shows the dots and crosses. This one shows dots and crosses with the circles. So there's not there's not much of a difference there, but yeah, obviously there is some difference. But yeah, so hopefully that makes sense. They normally specify which one they want you to draw in the exam. So don't worry about that. So you can represent the bonds in a covalent compound by showing either the highest energy levels or the outer shells. So you can represent the bonding in a covalent bond by showing A, the highest energy levels or outer shells, B, the outer electrons in a dot and cross diagram, or C, the number of covalent bonds. So you can either show the number of covalent bonds, you can show a dot and cross diagram, or you can represent the highest energy level electrons with with the circles, or you could just do it with the dots and crosses without the circles, or you can just show the bonds. And here I forgot to say that the oxygen, so here I forgot to just read this part out, that oxygen gas is made up of O2 molecules. Both oxygen atoms in the O2 molecule gain the stable electronic structure of a noble gas. Neon this time, because obviously it has, it will now have because it now has 2,8. Now it becomes 2,8, which is 10 electrons, because it was it had 6, but now they're covalently bonded. They both total of 4 inside. Hopefully that makes sense, because now, because it was originally 2,6, sorry, and now you have 4 electrons in the covalent bond. So now now you have the electronic structure of neon, because each oxygen now has 8 electrons in the outer shell, because originally it had 6. So then neon is formed basically, because obviously remember 2 electrons in the first shell, and now we have 8 in the next shell, because we originally had 6, but when sharing we had 8, so 2 plus 8 is 10. That's why it's neon, because neon has 10 electrons, because it obviously has atomic number 10, number of protons equal number of electrons. So 10 protons means 10 electrons for a neutral atom. We've gone through that before. And by sharing 2 pairs of electrons in a double covalent bond, and this is often shown as O double bond O. So O with 2 bonds. Wait. Don't know if you can see this clearly, but it's basically an O with 2 bonds and then an O. If it was triple bonded, you just have N and then 3 bonds. 3 horizontal lines, and then you'd have, it doesn't matter. I think nitrogen triple bonds, N triple bond N, So hopefully that makes sense. And then here's just a question. So draw diagrams using symbols and lines to show the covalent bonds in chlorine, hydrogen chloride, hydrogen sulfide, oxygen, and carbon dioxide. So I'll quickly draw them. For chlorine, remember that's in group 7. It'll only share 1 electron, so it'll have single bond. For hydrogen chloride, again, both hydrogen and chlorine, they're in group 1 and group 7. They only want to share 1 electron, because obviously, group 1 needs to only lose 1 electron to have a full out shell. Group 7 only needs to gain an electron to have a full out shell. That's why they're going to singly, they're going to have a single covalent bond. And then same for hydrogen sulfide, because obviously H2S, so H2S, that means they're 2 hydrogens. They're going to share an electron each, so that sulfur then has sulfur then can, because sulfur's in group 6, sulfur's in group 6 I believe, so they're going to have single covalent bond as well. And if it's oxygen, so O2 as well, so it'd just be double bonded, because obviously we've seen that before. And then carbon dioxide, well again, it's group 4 versus group 4 is carbon is in group 4 and oxygen's in group 6. You have 2 oxygens though, so each one needs to gain 2 electrons, so total of 4. So obviously they're going to have a double bond, they're going to have 2 bonds like that. So these should be the answers. For chlorine, single bonded to a chlorine there, hydrogen chloride, and then H2S, hydrogen sulfide, that's called, and that's hydrogen chloride, that's chlorine molecule there, Cl2, and then that's oxygen, obviously double bonded, and then that's carbon dioxide. So the last one's carbon dioxide. So basically that should be the answer. That should be the answers there. That one, hopefully it makes sense what I'm saying. If it doesn't go through the student book, hopefully it'll make more sense there, because obviously I'm thinking you've already done the content, so I'm just there for revising the basics, not going through things in much detail. Super. Don't need to go through things in a lot of detail, hopefully. But chlorine single bond, hydrogen chloride, HCl. Wait, have I done that right? Yes, I have. And the HSH, single bond, O double bond, and then OCO, double bond as well, 2 double bonds there. That's good. Now, just before we the keywords for this lesson were, is covalent bond, the only keyword, and then the key points just to finish off are that covalent bonds are formed when atoms of non-metals share a pair of electrons with each other. So here involves basically sharing a pair of electrons in covalent bonding. Each shared pair of electrons is a covalent bond. So basically each of the shared pair of electrons is a covalent bond. So for example, in why am I going to ionic bonding? What am I doing? Let me for example draw it out 1 minute quickly. So sometimes it's difficult to show. Basically this, for hydrogen, this would be a covalent bond, a dot and a cross there. So that is one covalent bond. So hopefully that makes sense. And then many substances containing Many substances containing covalent bonds consist of simple molecules, but some have giant covalent structures. And we're going to look at giant covalent structures. First we're going to look at giant covalent structures in C3.7, because C3.6 is all about structures of simple molecules. But most of the covalently bonded substances, most substances that contain covalent bonds are simple molecules. They consist of simple molecules, but some, obviously do have giant covalent structures. We're going to look at diamond, graphite, and I believe silicon dioxide as well. So yeah, we're going to look at that obviously in C3.7, but in C3.6 we're going to look at structures of simple molecules. But that's the end of the section, guys. I really hope it was useful. Make sure to share, like, and subscribe. And turn the notifications on if you haven't already, so that you're notified and updated when I upload new videos that you can watch. Thank you for the ongoing support. As always, I will try and I'll try. I'm not sure. I'll try my best to put the links to C3.2. Have I already put C3.2 on there? I'm not sure. I think I haven't. I think I've put it till C3.1 only. So I'll put C3.2, C3.3, C3.4, and C3.5 on there today, hopefully. If not, definitely by the end of the week. And tomorrow we're going to be going through C3.6, which is, what is it? It's structures of simple, structure of simple molecules. So yeah, until then, have a nice evening, and thank you very much, guys.